Okay, so we are going to do an experiment to demonstrate bacterial transformation, and we're going to initiate this in our lab. We're going to start with 2 E. coli samples, E. coli cells. E. coli is not competent on its own, meaning that it is unable to let large molecules like DNA pass through the cell membrane. But we're going to conduct an experiment. We're going to insert the E. coli cells with a recombinant DNA through the use of a plasmid, in this case a plasmid, to initiate horizontal gene transfer. So we'll have our plasmid here, and this has 4 sites on it. We have our ORI receptor site, the site where DNA polymerase will begin replication. We have the ARAC gene. This is the site that regulates the transcription of GFP, of the GFP gene in the experiment. So this is our active site for our sugar arabinose. Once we add the sugar, it will turn on the GFP gene, which is right here. The GFP gene codes for green fluorescent protein, which we hope to activate at the end of the experiment, turning our culture green, bright green, glowing green. And then I have the BLA gene, or our ampicillin resistant gene. This will code for the penicillinase. This gene will allow the transformed cell to survive on media with ampicillin, since it's resistant to ampicillin. To achieve this, to make our E. coli cells competent, we want to get an ice bath right here, and we want to add calcium chloride to it. By adding calcium chloride, the goal is to neutralize our negatively charged DNA so that it is more able to easily pass through the membrane of the E. coli, the cell membrane. So we'll expose the cells to the calcium chloride bath, and we will add the plasmid. And then we will take them out, place them in a warm water bath for about 1 minute. Then a minute passes, we take them out and we add it back to the cold water, the calcium chloride cold bath. And this is called a heat shock. So what should occur in this process is that the cells will take up some of the plasmid, some but not all of the cells will take the plasmid up. So we'll reflect the ones that are pGlow positive and the ones that are pGlow negative. So these ones took up the plasmid, and this guy did not take up the plasmid. And then next we want to place our culture, place it in a culture with some media to see our growth. So we're going to use Loria broth for our media. So at this point, both of our samples will be growing until we add our ampicillin. Now, only once we add the ampicillin, our pGlow negative will no longer grow because they don't have the ampicillin resistant gene. So bye-bye, you're dead. Only our pGlow positive will be able to grow, and replicate. So in the presence of our Loria broth and our ampicillin, only the new transformed bacteria is able to grow. But we can't make that happen until we activate that regulator site by adding arabinose. So we'll add the arabinose to turn on the GFP. And we add the arabinose, and ta-da, it worked, and our sample is now glowing with the GFP turned on. Yay.